Let's look at what happens now if you perform a dilation with a negative factor. Now, since dilations involve swapping out the x for x over a, or swapping out the y for y over a, where a is your factor, if we've got a factor of -1, that just means we're going to be subbing in -1 for a in both of those situations. And that's just going to give us negative x or negative y. So this is the exact same thing as performing a reflection. Because we've already seen this, if you swap x values for negative x values, you're switching across like this. And so we know already that a horizontal dilation, we said it had the y-axis as its axis of dilation because it's pulling things further away or closer to the y-axis. Well, it's also going to potentially reflect them around the y-axis if the factor is negative. And if we have a vertical dilation with a factor of -1, remember a vertical dilation stretches it this way and changes the y values, then it makes sense that it's going to, if it has a negative factor, actually reflect whatever we are reflecting around the x-axis. Now, if you have a factor that's not -1, but it's negative something, let's say it's negative a, then you can think of this as two different transformations, and it makes it much easier to perform them. Think of it as a dilation with a normal factor a, without the negative there, and then the negative part will also cause a reflection. And you can do these in either order. Now, something to think about, we saw that if you perform a dilation in both directions at once, horizontal and vertical, then we call it an enlargement, don't we? So if you're performing 180 degrees of rotation, for example, you're taking something that looks like this and rotating it around so that it sits down there like that, then we've seen with our reflection that what you're really doing is reflecting it either around the y-axis and then the x-axis, or in the other order, you're reflecting it around the x-axis and then around the y-axis. So it's actually a combination of both reflections. So we can similarly say then that it's actually a dilation of -1 in both directions, and we can call that an enlargement with a factor of -1. So for our example here, we want to perform a horizontal dilation with factor -2 on this parabola. Now this is the same parabola that we looked at in an earlier exercise today. Let's start by just drawing it. We can see that this is x squared minus 2x, but it's easier to work within this factorised form because I can let y equal 0 and see that x would have to be 0 or 2. So I've got a parabola because I know I've got the highest power of x here is x squared, and it's positive x squared, so it's an upright parabola. And it must go through the points 0 and 2 on the x-axis. So I can go ahead and rough in something like this. I can even label this point here if I like and say, well, it's going to be, the axis of symmetry will be halfway between 0 and 2, so it'll be at x equals 1. And if I sub 1 in here, I've got 1 multiplied by -1, so this is the point 1, -1. Now, to perform this dilation, I've got two choices. I can do the reflection first, and then the dilation of 2, or I can do the dilation of 2 and then the reflection. I think I'll do that first, the dilation of 2. So to dilate this horizontally with a factor of 2, horizontal dilation is going to pull it apart this way, isn't it? It's going to make it bigger. It's going to make everything further away from the y-axis. It's going to be twice as far. So what I need to do is I need to adjust my x values to not be x, but to be x over 2. So I'm going to do it like this, x over 2, x over 2 minus 2. So now if I let y equal 0, I've got x over 2 is equal to 0. In other words, x would have to be 0. Or x over 2 minus 2 is 0, so x over 2 would have to be equal to 2, and x would have to be equal to 4. So these are my two x-intercepts, 0 and 4. Now it's a horizontal stretch. That means it won't dip down any lower than it used to, it's just going to be stretched out. So my vertex is still going to sit here level with -1, but it's now going to be halfway between 0 and 4. So I can pretty much just rough that in. And let's do this in another colour and say that with my factor of 2, I've got something like this. It's basically just a fatter parabola. Now this one is y equals x over 2, x over 2 minus 2. So I've performed this first dilation factor 2, but I haven't done the negative part yet. Now the negative part, a horizontal dilation of -1 is what I want here. And that means if I'm going to make a horizontal dilation of -1, that's the same as replacing x with -x. So that means it's going to flip it around the y-axis. So I can take another colour now. Let's make my final answer be in blue. This point, when it's flipped, is still going to be exactly where it was, but this one, instead of being here at 4, is going to flop over to the other side to -4. And this point here, which was at 2 minus 1, is now going to be at -2 minus 1. And now I've got enough points here to pretty much just rough in my parabola, and I've made my dilation, and this is my final answer. Now, to my way of thinking, that was quite an easy way to tackle this question. I performed the factor 2, and then I performed the factor of -1, and that gave me the reflection. Another way I could do it would be to algebraically use my factor of -2 right from the start and rewrite my equation with, instead of x over my factor, which is -2. Now, what would that have looked like? Well, let's have a go at that so we can see whether it would have been easier. We would have had x over -2 and x over -2 minus 2. Now, that would give us, if we let y equal 0, a chance to solve this fairly easily and come up with our x-intercepts. You could also expand it out just to double check what this looks like. X times x is x squared, and -2 times -2 is 4. And here we'd have a plus, what have we got, 2 plus x. And then you could refactorise that if you wanted to and say this is actually just an x out the front of x over 4 plus 1. Now, if we let y equal 0, we can see that either x is 0 or x is -4, because -4 divided by 4 plus 1 equals 0. So always more than one way to do things. You can do everything in one go algebraically and fiddle with it till you get to the point where you can just draw it in one go. Or you can perform a dilation of 2 and then a dilation of -1, or vice versa, and all those methods will take you to the same thing.